Dr. Aziza Habib. I'm currently working as an assistant professor in the Department of Physiotherapy in Jaipur National University. This is JNU Hospital and Medical College. Today I'll be taking your lecture on BOP2, that is Basics of Physiotherapy 2, which involves electrotherapeutic devices. Physiotherapy treatment comprises of 70% of manual techniques and 30% of electrotherapeutic techniques. When you talk about electrotherapeutic techniques, the one concept which comes in our mind is physics, because there is a gross relation between the concepts of physics and electrotherapeutic devices. So here I have tried to highlight some of the basic concepts of physics to have a gross knowledge of electrotherapy. So I'll be starting with introduction with basic physics. The topics which I'm gonna cover are: first, structure of atom; second, Bohr's model or Bohr's atomic structure; third, electricity; and force will be our fourth topic of the day. The structure of an atom. Atom is made up of positively charged particles or nucleus surrounded by negatively charged electrons. Nucleus is present at the center of the atom and it is highly concentrated. The electrons revolve around the nucleus in various circular orbits. The atom is made up of subatomic particles which are known as electron, proton, or neutron. Electrons are negatively charged particles with a mass of 9.109 into 10 to the power minus 31 kg. Protons and neutrons make up the nucleus, which contain all the masses of the atom. Protons are positively charged element, while neutrons are neutral, but both proton and neutron have a mass of 1.67493 into 10 to the power minus 27 kg. Electrons and protons have charges with the same magnitude of 1.602 into 10 to the power minus 19 coulomb. As we all know that coulomb is the unit we use for measuring electric charges. So electrons and protons have the same magnitude of charges, but their nature is opposite. Now we will discuss the second topic for the day, which is Bohr's model of the atom or Bohr's atomic model. According to Bohr, every atom consists of a nucleus in which entire positive charge and mass is concentrated. Electrons revolve around it in circular orbits. Electrons can revolve only in certain orbits which are known as stationary orbits, and for these orbits the total angular momentum of the revolving electron is an integral multiple of h by 2 pi, where h is our Planck's constant. Now the third topic is electricity. When you talk about electricity, there are some fundamentals. So first we will discuss the fundamentals of electricity. A property of electrons which give rise to electric force between two electrons is called electric charge, or in simple words we can say that electricity is the flow of electric charge. Now there are certain terms like conductors and insulators. Substance which can carry or conduct electric charge from one place to another are known as conductors, and the very good example of conductor is metals, while insulators are just opposite of the conductors. Insulators do not contain the property of carrying electric charge from one place to another. Now the third thing we're gonna discuss is Ohm's law. It states that under constant physical conditions, for example temperature, the current flowing through a conductor is directly proportional to the potential applied on its two ends. For example, if I take a wire in my hand and the electric current is passing through it, okay, so that electric current which is being passed in that wire will be directly proportional to the potential which will be generated at the two ends of the wire. Means V will be directly proportional to I, or I will be directly proportional to V. Then V is equals to IR, where R is the resistance offered in the flow of electric current inside the wire. Now, we talk about fundamentals of electricity, we talked about conductors and insulators, we talked about Ohm's law. Now, we will discuss the effects of electric current. Some of the effects which are very common by the production of electric current are: first will be your heating effect of current. We all have observed that whenever electric current is passed through a conductor or a wire, that object gets heated up. Why? Although this is called heating effect of electric current, which comes into existence because of the collision of electrons with the ions of the conductor. When there is a collision between the ions which are present inside the wire with that of the electrons which are being flowing in that wire, then the thermal energy which is being produced inside that conductor will be resulting as the heating effect of current. Now, magnetic effect of current. As we all know, when a current is being passed in a conductor or, for example, in a wire, then the magnetic field is being produced along the line of its propagation. Along the line of the propagation of current, surrounding that a magnetic field is produced. So this is called magnetic effect of electric current. For this magnetic effect to be produced, the charges are required to be in motion. Now we will talk about the chemical effects of current. The property of electric current Now we will talk about the chemical effects of current. The property of electric current to cause certain chemical reactions in conducting liquids or inside conductor is called chemical effect of current. Now, the last topic will be our force. What is force? If you talk about the basic definition of force, then it is any push or pull exerted by one object onto another. So basically, a force is a push or pull upon an object resulting from the interaction among those objects, right? So when there is force, then there should also be the resolution of forces. It is defined as the process of splitting up the given force into a number of components without changing its effect on a body. A force is generally resolved along two mutually perpendicular axes. Okay, for example, if there is a certain amount of force like F which is being imparted on a surface, so it will be resolved into its constituting components, which will be, if you consider that constituting components along two axes which are majorly x and y axis, then that gross force F will be divided into Fx and Fy, and the angle which is being imparted by that force onto the surface will be theta. Okay, and this Fx and Fy will be perpendicular to each other. Now we will be talking about equilibrium of forces. For example, if an object is placed over there and a lot of forces from all the direction, for example, like multi-directional approach of force is being applied on that object, but the resultant force is zero. So this state of that object will be known as equilibrium state, right? And it is not necessary that the magnitude of all the forces being applied on that object from all the directions is same. It is not required but their resultant should be 0. Now, another term is, we are very much introduced with this term, which is gravitational force. As we all know that all the objects in the universe attracts each other with a certain amount of force, which is a universal force and popularly known as gravitational force. For example, two objects are placed over there with a mass of, object 1 is having a mass of m1 and object 2 is having a mass of m2, and the distance between them is r. The forces which are being imparted by those objects are F1 and F2 consecutively. Then the net force which can be calculated as F1 is equals to F2 will be G into M1 upon M2 upon R square. Now the next term which we'll be broadly discussing is Newton's law of motion, because these are the universal laws. The first law of motion, Newton's first law of motion says that if a body is in rest or at motion and it continues to be in that state until and unless an external force is being applied on it, this law is known as law of inertia. Now we will be discussing the second law, which is the time rate of change of momentum of a body is equal in both magnitude and direction to the force imposed on it. It can be depicted as F is equals to ma, where F is the mass, F is the force, m is the mass, and a will be your acceleration. Now we will be discussing the third law of Newton, which is popularly known as the law of action and reaction. So when two bodies interact, they impart force on each other, which is equal and in magnitude but opposite in direction. So this is the third law of Newton. Now another term is torque. Torque is the measure of the force that can cause an object to rotate about its axis. It is the analog of force. So torque will be represented as R into F into sine theta, where R is the distance, F is the force, and theta is the angle. Work. Another definition is work. We can define work as a measure of energy transfer that occurs when an object is made to move over a distance by some external force. So W is equals to F into S, where W stands for work, F stands for force, and S stands for the distance covered. Now we'll talk about energy. Although energy is a broad term, but the basic definition used for energy is the capacity of doing work. Okay, it may exist in various forms. Some of the most popular forms of energy are the potential, kinetic, thermal, etc. So, what do you mean by potential energy? It is being generated by an object which is steady in nature. Kinetic energy is imparted by a moving object, and thermal energy, as we all know, happens because of the production of heat. Now we will be discussing the last two remaining topics for the introductory part, which is power. Power, as we all know, is the rate of doing work or the rate of transfer of energy. So you can depict power as P is equals to W by T, where P represents power, W represents work, and T represents time. Or we can also say that P is equals to E by T, that is energy, rate of energy. Now the last topic is friction. What do you mean by friction? Well, everybody knows that it arises when one object is made to move on another object. For example, if I place a book on this table and I try to push that book along the surface of this table. So in between both the surfaces, surface 1, book, surface 2 is table. So there will be a resisting force which is being created, which is opposing my energy, by which I am trying to move that book on the table. So friction always work in the direction opposite to the direction in which the moving object is there or we are trying to move the object. So this was all from my side. I hope the basic concepts have been clear to you all. Thank you so much. Have a nice day. God bless.